Okay, guys, can you hear me all right now?
Yes, perfectly.
Wonderful, wonderful. It
So
needed a bit of, I had to reconnect, so that's why. Okay, I'll quickly crack on with my presentation.
Yes.
I'll share my screen.
So just please follow the time. We have a limited time in 10 minutes. If you could go over that, I really appreciate it. So you could start. Thank you.
Yes, thanks a lot. Can you see my screen, please?
Yes, very good.
All right. Well, thank you. Thank you so much, Professor Mamadari, for kind introduction. And after all these glitches, now we are here. And thankfully that my colleague, Dr. Arya Asadi Langrudi is there. So he has been updating me about the time. So my name is Javed Qureshi. I'm a senior lecturer at University of East London in London, United Kingdom. And in today's talk, I will be talking about the recycling of fiber reinforced polymer composite materials. And again, my apologies for not being there in person, and I've really enjoyed today's presentations. So this is how my presentation is organized today. So first I'll give some background, and then global market share of FRP structures, and then strategies to recycle FRP and their pros and cons. And then after that, the cost of recycling methods. And finally, I'll draw up some conclusions. Now, construction produces about a third of global carbon emissions, and there is a need to reduce these carbon emissions by use of sustainable technologies and sustainable materials. And FRP is such sustainable material with lower carbon footprint than traditional materials. In simple terms, FRP is simply carbon or glass fiber embedded in resin matrix. Now, for civil engineering applications, there are mainly three applications where we use FRPs. So FRP profiles for new build structures, FRP rebars in concrete, and FRP in strengthening. Now, the key driver behind using these materials is lightweight and corrosion resistance. But because these structures have been in use for last 30 to 40 years, recycling them is a major challenge. And in today's presentation, I'm going to talk about some tools and strategies to recycle these materials. Now, this is an example of Dawlish Bridge, which was constructed back in 1937. And it became beyond repair. So an identical bridge was produced, which is made up of FRP back in 2011, and it had no corrosion. Even it survived 2014 storms in the UK and was corrosion free. Now, global market share of FRP. According to JEC Group, the production of FRP is as much as 100 billion US dollars, and the volume that is more than 12 metric tons. And it has applications in more than 15 industries, including marine, construction, and aerospace, and transportation. And the industry is set to grow between 5 to 6% over the next 5 years. 95% of all FRPs is glass FRP, and 75% use thermoset resin. Both of them are very difficult to recycle. And this is the market share. You can see that construction, global market share on the left side, it uses 26%, automotive 31%, marine industries, it is used in wind turbines as well. Now, interestingly, in 2020, the market share in Europe, it increased to 37%, which is quite promising improvement. Now, with that much application, the key issue here is recycling. So how do we recycle? And how do we dispose of the materials? So the waste is generated from production, or it is generated from use. And for as much as 40% of waste is from production, which ends up in landfill. And landfill and incineration are traditional ways to dispose of this material. But as Professor Rafat said today, that there might not be space in landfill and there might be regulation. So across Europe, there are strict laws for dumping. But in United States, I mean, almost certainly you would you would dump it off in landfill. GFRP waste in Europe is about 304 kilotons, which is about 1/3 of its production. Now, what do we do with this waste material? So firstly, the material is cut and then transported. Then the strategies that we can use, it can go into landfill, and then we can incinerate or co-incinerate. The incineration is a burning process which produces kind of ash. The benefit of co-incineration is that there's a clinker which we can use in concrete. Now, there are three methods for recycling: mechanical, thermal, and chemical. Mechanical recycling is only commercially viable method, where we grind the material, we shred the material to reduce it into smaller parts. Other two are not commercially viable, and it requires a lot of money to certainly use those methods. Now, pros and cons. Landfill is quite cost effective, but certainly it leads to a lot of pollution, and it can create lots of greenhouse gases as well. Incineration and co-incineration, they have benefits, but they produce ash, which still needs to be a landfill. And again, it is these methods are quite expensive to build, and skilled labor is required for incineration and co-incineration. Recycling, on the other hand, it protects the environment and it reduces the greenhouse gas emissions, and as a result, I mean, it would be useful for climate emergency. But again, the initial cost is really high, and the materials extracted, they may not have the same properties as the original virgin materials. And some of the processes may not be commercially viable. So for example, chemical and thermal recycling, they can only be used at a very small scale. But if you wanted to use them for larger scale, then you simply use mechanical recycling. Now, the cost analysis. Now, here you can see that landfill is the cheapest way to obviously dispose of the materials. But again, we may not have a space in landfill. It may not be suitable, and there might be very strict laws like in Europe. And out of two recycling processes, mechanical pyrolysis is again a type of thermal recycling. Mechanical is the cheapest one. And you can see that the chemical recycling, it costs huge money. So by all means, when the value of fiber is really high, like carbon fibers, this kind of recycling technique can be used. If the value is low, I mean, certainly it would be very difficult to use chemical recycling. Now, we have to come up with some innovative ways to deal with recycling when in many occasions recycling is not possible. So here on the left, you can see wind turbines, glass FRP. In the middle picture, you can see that the wind turbine blades, they have been used as bridge, as a footbridge. And I recently met up one of a colleague in America, Professor Larry Bank, who are working on this project, and they have actually produced a bridge. And on the extreme right-hand side, you can see that these wind turbine blades, they are being used as electricity transmission towers, so which is quite a useful use of this material. And then again, in the order of priority, we reuse the material. If it is possible, then repurpose it for different applications and recycle or recover, or we can co-process, incinerate, and the final one is landfill. So the conclusions are that recycling is a very major challenge, and we have to think in different ways to come up with new technologies. And landfill is the cheapest option. Mechanical recycling is certainly commercially viable, and low cost glass FRP is very difficult to recycle. And reusing or repurposing is the way forward. these are some of my references. And thank you for listening. You can get in touch with me on these emails, and the copy of presentation is available at this side. Just bang on time. My clock says 10 minutes are over. So I don't want to take more time, and I'll be happy to take any questions at the end. And please have a look at this review paper. Thank you.
Okay, thank you so much. Thank you so much for your time as well. I know that you were waiting too much.
Yeah, definitely.
Thank you for your patience. Thank you so much.
Thank you. Thanks a lot.
So now I would like to invite Asli Bahire Barda.